Thank you everybody for being here. I apologize the video did not record the first time, so I'm going to try to go through as best I can, doing the same thing I did last time, so I catch all of that in the video. And I know several of you were not either able to make it or all of it, so hopefully this will be helpful. Now, what we did last week when I was not able to get the video at all was I just introduced Python a little bit. Just to review, Python is a very popular programming language. It's used in a lot of different disciplines. Specifically, it's used a lot in data science, and data science is the building block for artificial intelligence. So that's why we're using it in this course here. Python's also very commonly used in web pages. There's a framework called Django and another one called Flask. And there's a few other ones out there that allow you to make web pages with Python. And so it's become pretty popular in the web development world also. And it's also popular with system administrators if you are doing something with typing, doing like you want to automate your backups or do other kinds of things. Python is very powerful there. So those are three big areas. It can be used actually in a whole bunch of other areas also. But I just wanted to kind of give you an idea that I think Python is a good language to learn for that reason. It's also considered one of the easier languages to learn, although it does have some things that are tricky also, as we will go through on some of these things. And I will show you some of the little getchas around along the way. I try to have this being a class where we learn by doing. So we will be writing code. You can, I hopefully have an editor up and following along if you're watching this video. I hope that you will pause it when you need to. But since everybody who's here live with me right now, please go ahead and if you need to pause me and say, hey, I need a little more time, or ask me questions, please take the time to do that. I'm sure that those who will be watching the video also will benefit from having questions answered. And I want to start from the very beginning on this. So last time I gave you all the challenge to write basically the simplest program that exists, and this program pretty much exists in every computer language, and by tradition is the first program we learn, and it's called Hello World. And I wanted to give you a chance to be able to just do Hello World on your own and try it out, but because I knew there'd be tons of web pages that would tell you how to do this, and it is just so simple. But if you did have some troubles with Hello World, I'm going to go ahead and do it now. This is the Hello World program, and you start with print in Python. This is a function that we're going to do, and we're going to say in print what we're going to want to print on the screen. And in this case, we're going to want to print Hello World. Now, this is called a string. A string is just basically text that's going to be shown. And sometimes I'm going to end up with maybe using some language that I forget to explain. So if I ever use some language I forget to explain, like string, please stop me and say, hey, what was that again? Or what does that mean? And I will do my best to do that. So whenever we print a string, we got to start it with quotes, and we can use single or double quotes. They both have advantages and disadvantages. Well, they're not really a big deal, actually, I should say. I usually use double quotes because, can I do what? Oh, can I zoom a little bit? Is that bigger? Is that easier to read? So I'm going to go ahead and say print quote hello world exclamation point. That's the Hello World program. So if you were expecting something more grand, that's it. But it is kind of grand because it is the first program that we tend to write, and it says Hello World. And we press the little play. Now I'm using, for my editor, I also asked everybody to get an editor last week. I'm using Jupyter Lab. This is because the recording software that I have can record Jupyter Lab. Also, Jupyter Lab is a very popular editor for Python for data science, Not as much into artificial intelligence, which is more interactive, but again, data science is like the foundation for artificial intelligence. And so I will use artificial intelligence and data science, and also sometimes machine learning. They're all very related to each other. Sometimes I'll use those kind of interchangeably, even though they are different. And we will talk about the differences as we go along. By the way, Jupyter is spelled Jupyter, and that Jupy, the py is for Python. You'll oftentimes hear things that have pi in them, and the R is for another programming language that's used a lot in data science called R. And so they both have these things. Python, by the way, I did mention this last week. It's actually named after the group Monty Python, because nerds, we have weird humor, and so it's not named after the snake. It's named after the comedians. So now that I've done Hello World, we're going to actually do today, and I sent this on the list. We're going to do a program that's going to simulate what's called the Monty Hall program. Not Monty Python in this case, but Monty Hall Problem, I should say. And the Monty Hall Problem is based off of the game show Let's Make a Deal. Now, Let's Make a Deal, I'm going to show you a screenshot of a video from it. Now, I'm not going to actually play this video because that's when my video recording stopped last time, but I hope you can see this here. This is from the 1980s, and it was even earlier than that. A game show where this guy named Monty Hall would come down, and there were these 3 curtains or 3 doors that basically contestants could choose things between these doors. And Monty Hall would give you options, and you could trade for this, or you could choose that one, or things like this. Well, this is the way we now call the mathematical Monty Hall problem, is if you were a contestant on this game show, you would be given the chance to choose one of these 3 doors here. So why don't I have somebody tell me a door that they would pick? Okay, so if you pick door number 1, Monty would say, well, before I show you what's behind door number 1, let me open up one of the other doors. And he would either open up door number 2 or door number 3. Oh, and by the way, I should set this up properly. Forgot to say this. You know that one of the doors has a car, which you want, and the other 2 doors have goats, which you don't want. So you're not sure, does this one have the car? Does 1 have the car? Does 2 have the car? Does 3 have the car? One of them has a car, and the other 2 has goats. So if you chose number 1, he's going to show you another door, but he's not going to show you one that has the car, because he's going to ask you if you want to trade. He's going to ask you something else. So he's going to show you one with a goat. So let's say you chose number 1, and he shows you door number 2, and he says, well, before you do this, I'm going to show you that door number 2 has a goat. So you've chosen door number 1. Do you want to switch now to door number 3, knowing that door number 2 has a goat? And here is the probability issue, that the thing that comes up here. The probability thing that comes up here is a question about whether probability-wise you're better off staying with number 1, or whether you're better off changing to number 3, or whether it doesn't make a difference. And this right here is a very weird portion of probability. And in fact, probability is often very counterintuitive, but we're covering probability because, and we're covering this as a game because almost everything that we do in data science and artificial intelligence, 1, boils back down to probabilities, and so it's good to learn this. And 2, a lot of artificial intelligence applications have started with games. And so that's why we're programming a game first. So I wanted to cover that also. So what we're going to find out in the end is whether it is better to stick with number 1, or it's better to go with number 3, or whether it wouldn't make a difference. And by the way, I have been working to understand this problem almost for 20 years. And only very recently do I feel more comfortable that I'm kind of getting it, why the answer is what it is. So if you don't understand this at first, don't feel too bad, because this is one of these things where a lot of folks struggle, myself included. Reminds me a little bit of what the great quantum physicist Richard Feynman said, and I'm going to kind of paraphrase him about quantum physics. And he says, well, you know, nobody really understands quantum physics. We can do the math, but we don't really understand it. And sometimes I feel that way about some of these things. We'll be able to do the math, but it's not like we'll always be able to do it. Like, especially when we start with dealing with higher dimensions, we can kind of get it. I'm going to do some things to try to help us understand how higher dimensions might work, but we're kind of limited with our brains to be able to see 3 dimensions that we have right now. So I'm going to just say that right there. Let's go ahead. I'm going to go back over to Jupyter Lab, and we're going to make, first of all, an even more basic program game than what the one I just did. We're just going to make a game for right now for ourselves, real simple, where we pick one of the doors and it just shows us what it is and whether it's a goat or a car. So that's the game we're going to start with first here. We're going to program this game together, a simple game of chance, and we're going to then do a lot of, we're going to improve this program. This is very common in computer programming, to start with a basic program and then you improve it. Sometimes those improvements add new features. Sometimes they don't add new features, but they improve how it works in the programming language itself. We call that refactoring. So those are both very valuable things right here. So I'm going to come over back to my Jupyter Lab, and I'm going to be here. And what we're going to do first is I'm going to create what are called some variables. And variables in programming are kind of similar to what variables are in algebra. I know not everybody may have done algebra or remember algebra that much. But like in algebra, we might say x equals 1 or something like that. And we can do that in programming languages like Python. But I want you to think of a variable more like a pronoun sometimes. So for example, I might say my son's name is Riley, and he is joining us for these classes. When I use that word he, you know that meant Riley, because Riley was kind of assigned to he. So when we're dealing with variables, you can almost think of them like a pronoun. It's something where we say this word, but it means something else. So in this case right here, I'm going to make 3 variables at first that are going to be the 3 doors. And the variables are just going to contain a word that's going to tell us what's behind that door. So to do a variable in Python, you can just start with a variable. A lot of languages you have to initialize the variable. In Python, there's some things you need to initialize, but variables are not, the simple variables are not one of them. So I can say door underscore 1. We do a normal equal sign. This assigns something. And I'm going to say this is a, what did I do last time? No, that doesn't do it for me. I'm going to go ahead and I think this one right here is a goat. Yeah. Okay, door number 1 is a goat. And door number 2. And please, if you can, go ahead and type these along in your editor, whichever one you have. Door number 2, cheating here, that was a car. And door number 3 is another goat. Because 2 of them have goats and 1 has a car. The thing I want to mention here about this is that I'm using Python style. We're going to talk in the future about PEP 8, but this, when you're doing variables, even though we could use uppercase, it is considered good style to do all lowercase and to separate words with an underscore. Now, you're going to find when we go a little bit further in the future there's some disadvantages of having these three doors all having their own variable. This is not really the best way to do this program. In fact, it's going to run into some limitations pretty quickly, but I'm going to try to show you the basic tools and then build up from there. And we're going to get through a fair number of the basic tools of computer programming today. And if any of these things, you can ask me questions on them. If you struggle with some of these things, there are lots and lots of web pages also on helping out with these. Although I know as a beginner, it's harder to use those web pages because you're using language you may not understand yet. So the more you know what you don't know, which means that the more you can learn more easily. So I know the beginning stage is one of the most challenging parts here. Okay, so I have three doors. And then what I'm going to do is I am going to have another variable here. And I know I'm going back and forth to my cheating kind of here, but I want to kind of make the same program I made last time. Is we're going to make a variable called guess, like what the person is guessing. And we're going to use a thing called input, which is another function, which basically this particular function, when I say function, it's just something that does something. It usually returns some kind of value. Like this is going to, when I say input, this input's going to send it into guess, because guess is equaling whatever the input is. And input just doesn't even ask, but it says something on the screen and it returns a string. Again, a string being text, and text within quotes, either with single quotes or double quotes. So input, okay, I'll slow down a little bit here. Okay, well, that's okay. And if you don't get it all typed in, that's okay also. So I'm going to say guess equals input. Which door do you choose? Question mark. And I'm going to put a space after that question mark here. And then an end quote. So what this is going to do is it's going to set our three doors, and it's now going to set a guess. Three doors right now are what we called constants because they're just one thing. They're not changing, not at the moment at least. But guess is more of a variable that's actually like a variable because we're going to choose different things. Maybe the first time we guess 1, maybe the second time we guess 2. So these are things, but these are all four technically variables. And so if I was to run this program right now, it wouldn't really do much, but I'm going to go ahead and do this. It's going to say just which door do you choose? And I can type in pretty much anything. I can type in 1 and it doesn't do anything. But now guess is actually equal to 1. I can run it again and say 2. Doesn't seem to do anything. But in fact, just to show you that it is doing something, I'm going to say print you chose door number. And I got to put a space bar here because if I don't put the space between this quote, it's going to just run number and the next thing together. So I have to have a space. And then I'm going to use a plus sign here to say guess. This means concatenate, which basically means append it to each other, put them together. Concatenate's one of these big words. We oftentimes call it cat or concat in programming. It's a very common word, but I know it's not common in normal English. So we are going to take this guess and put it on here. So if I run this program now, and by the way, we're going to take this out probably, but I'm going to run this. And if it says, if I chose door number 1, it's just simply going to say you chose door number 1, because what happened here was guess was my input, which door do you choose? And then print, I said you chose door number, and then it put in guess. Okay, before I go further here, is this making sense? Because I know sometimes these things right here, especially when you're first starting, it doesn't always make sense. Okay. I'll give a little bit more time. Now in the video itself, you of course can just pause it when you're doing it, but with the students here, I will give you a little bit of time. Don't worry if you can't get the print statement. How far through are you, Riley, on your typing? Okay. Okay. So, what we're going to do now is now that they've actually chosen a door, we are going to now see what's behind that door. And to do this, we're going to do what's called an if statement. So if guess, and last time I did this video I made a mistake. I just said equal sign, guess equals 1, and then in Python we don't say if then. A lot of languages use the then command. We just simply put a colon. So if guess equals 1 colon. Now there's actually, I'm going to go back and do another thing here. I'm going to show an error. If I write it this way, if guess single equal sign 1, I have a problem. A single equal sign means assigned the number 1 to guess. And in some programming languages like C and Java, it'll actually let you do this and it'll screw you up. I've done that way too many times because there are a lot of programming languages you just use a single equal sign, like Basic and Pascal, which were some of the languages I learned first. So if you want to be able to do it so that you have that you're saying does guess actually compare it to 1, are they the same? You need to put in 2 equal signs. The other thing is sometimes we do deal with numbers just as numbers. You will see we'll be doing that in the future. But right now, input, even if we type the number 1, it doesn't come back as a true number. It comes back as a character, which is same as a string. And so we have to basically say if guess equals quote 1, then we're going to do something. So I'm going to go ahead and say if guess equals 1, and we're just going to say, we're going to do print, and we're going to say print, sorry, you got a goat. And you can see that's because door number 1, we said, was a goat. Now, one of the things we're going to talk about here is that in this case right here, we're not actually using a variable. This is all static, meaning it just stays the same. And because door number 1's a goat at the top, I didn't even have to look at the variable. I could, but it actually makes a computer program more complicated, and I'm trying to keep this pretty simple at first. By the time we're done, though, we will be using true variables here. Okay, well, I'm going to type a little bit more, and then I will pause for a little bit so you can catch up, okay? So keep typing as I'm going. Now, if guess doesn't equal 1, we can say else if, and I have to remember if, actually, here's my problem. In Python, it's elif guess equals, and that basically means else if, guess equals 2, in quotes, equals 2. Then we're going to print, you won a car. And it could also be guess could be equal to 3. Not 3. There. Brain was thinking 3 and it put in 3 equal signs. So if it was 3, we're going to print the same thing as we did for 1. Sorry, you got a goat. And last, else, How do you spell one? Oh, like you won the game? It's right here, W-O-N. I have it right there. Okay. And then last but not least, if they don't choose 1, 2, or 3, we want to just kind of do what we call error capturing, or there's other words for this. But basically, we want to make sure that if there's an error, that we do something, that we don't just have nothing show up. And we're going to talk about different kinds of errors as we go along. But for right now, I'm just going to print here. I think last time I said, sorry, I did not understand. So that's what I'm going to do. Sorry, I did not understand. And there's one more thing I'm going to change. Like I said, I put this print in here temporarily up here. That's kind of for doing debugging. As we get more advanced, we're going to learn about logging features, where you might have a debug mode and it will show you something on the screen when you are doing debugging, and then other times it won't show it. It may save it even to a file so that you can be able to access it later. But I'm going to put a pound sign in front of print. All that does is it basically, it's used sometimes for things called comments, which means we can put in other things to tell us what the program's doing. Or in this case, we oftentimes also will use these pound signs to say, don't run this line. Just don't do anything with it. So I'm not going to have the print about what door they chose, because I'm just going to have it say, hey, either sorry you got a goat, or you won, or sorry you got a goat. I'm going to go out a little bit here, just so hopefully this all can fit on one screen. Is that still big enough that you can actually read the words here? Yeah, okay, good. Okay. I understand you need time to write it. Okay, so what I'm going to do here now is I'm going to go ahead and press play to run this game. And, oh, I made a mistake. Not surprising. Kind of good, though, that I'm making mistakes, because I want you to also know that it's very common to make mistakes in programming languages. I don't understand. When you're, speaking of mistakes, suddenly my Google just said, I don't understand, thinking I was talking to it. And I took once a class over at Stanford University. I never was a Stanford student, but I had the fortune, while I was teaching more full-time, to actually go there for kind of a professional development with some of the professors that were teaching artificial intelligence there and data science. And one of them said, hey, this is something I always appreciate. I always try to do my coding and that students see mistakes, because they get to see how real-world coding works and understand that they're going to make mistakes also, and that we all do it. So in this case right here, what happened was I just forgot to put the colon at the end of else. This is called a syntax error. It says syntax error, invalid syntax. Syntax just means you wrote it wrong. You wrote something wrong someplace. Now sometimes it's hard to figure out what you wrote wrong. It looks right for some, and maybe the error is not always great. In this case, it actually is pretty helpful. It says else, shows a little, what we call the caret, pointing right here. There's something missing. It'd be nice if it said, hey, you're missing the colon, but it just says syntax error, invalid syntax. So I have to know, oh, I'm missing the colon. Okay, so I'm going to come back up. I'm going to try running this program again. That's what we do. Doesn't work the first time, you try again. So somebody other than Riley, Riley, you probably want to tell me a door to choose, but why don't I have somebody else give me a door that they're going to choose here? Moosin, you want to give me a door to choose? Or Chelsea? Door number 1. Okay, you want the goat. You want number 2. Okay, well, so we did door number 1, and it says, sorry, you got to go, because guess was 1. So let's go with Moosin's thing now. And I'm going to choose door number 2. And he was a little bit better on his guessing. He got the car. So why is this? Well, up top we know that number 1 was a goat, number 2 was a car, number 3 was a goat. But actually, again, these really are not being used right now. They're just kind of telling us what these things are. But what's really the logic of this code is first of all, we put a guess in. And we put that because input says, hey, whatever they type in, which store do you choose, put that in guess. And then we do these if statements and elifs and else. So if the guess was equal to 1, that was the first time we chose, we got the goat. Because it says print, sorry, you got a goat. But the second time, when we did this and Moosin chose 2, it says if guess equals 1, well, it didn't equal 1. We had guess 2. So it skipped past that, jumps to this elif, which is an else if statement. Else do this, else see if this is true. And so it said guess equals 2. And sure enough, the second time we did it, it's going to print you won a car. And it never gets to 3 because once one of these are found to be true, it doesn't go any further. So that's how if and elif statements go. So it never had to even look at these other ones. It just says you want a car, and that's what it does. At least if we're using elifs and elses. Now I'm going to choose. I'm going to pick a door this time, and I'm going to pick door number 4. Well, of course we know there was no door number 4, and so what happened here was it did the guess was equal to 1, no. Guess equals 2, no. Guess equals 3, no. So at the end it says else, if you didn't choose one of these, if none of these are true, it's just going to say, hey, print, sorry, I did not understand. And that's what it printed for me there, because 4 is not an option. Does this kind of make sense about what it's doing here? We're getting something, we're getting the input of the guess, and then we're just going to see if it equals 1, 2, or 3. Any questions? How are you doing on the typing there, Riley? Do you have most of it in? Your microphone's off, Riley. Okay, well, we'll have to come back and look at that. If it's not quite working, we'll debug it after we're done, okay? And that's not uncommon. We all spell things wrong sometimes. Hey, it's good to have you here again, Jedley. I hope the internet connection works okay. So, I know you said you were able to get your computer a little bit more up and running, right? Wonderful. So, I know if you can, type these things in right here. And I am going to go ahead and just to make it easier for all of you here, I am going to write this into our group here real fast. And if you want to copy and paste this into your text editor, and you can even do that, Riley, this should help you out. The only thing you have to do is if you copy and paste it, and I'm going to also, so if you don't want to have to go back into LinkedIn, I am going to put this into our Meet here also. So give me one moment, and I am going to see if I can write this and send it. Oh, and that one even has the indents. So if you're in Google Meet, you should be able to go over to the chat, and you could just copy and paste this into your editor and get caught up to where we are. And I'll try to do that along the way, because I know sometimes it's hard to type everything in as fast as I'm going. I don't want to pause too long. Okay. So far, so good of understanding this here? Okay. That makes sense. That's a good thing. And why is that? Ah, okay. That works. Okay, so what I'm going to do next here is we're going to actually try to start to use these variables at the top. But in order to use them and to make them work the best, we're going to create something called a dictionary. A dictionary in Python is a lot like what a lot of computer languages call arrays. And in fact, when I was first learning Python, I struggled with learning it because I had been programming for a while and it had all these new terms and called things that I did not recognize at all. It took me time to get used to what it was talking about. Um, but then, once I realized why it's doing what it's doing, and how, there was a lot of things I really liked about it. But what we're going to do is, if you make a dictionary is kind of like a group of variables, all kind of into one. You have to initialize it. So I'm going to say door equals, and you put in these curly brackets, and this is just going to create a blank dictionary. And again, we're initializing it. We're just kind of starting it. We're telling, hey, create a dictionary. And then down here, instead of having these being door underscore one, we're going to use these as specific, what we call indexes or keys for the door. And when I say key, I don't mean like a key in a door, but basically this is going to be, we're going to have the door dictionary have 3 different kind of variables in it: door 1, door 2, and door 3. The code looks very similar, but it's actually going to act differently. And we can do things different when we are able to do this. We're going to change our if statements down here to handle this this thing. So instead of saying, I'm going to still say guess equals the input, but down here, if the guess is equal to quote 1 end quote, we're not going to do that this time. We're going to try to start to use these variables. And it's going to be a little bit different here. And I always have to think about this for a moment. So if door, and then guess has a number with it, right? Guess is going to either be 1, 2, or 3. So if door guess, meaning door 1 if I chose 1, or door 2 if I chose 2, or door 3 if I chose 3, is equal to goat, then it's going to do this. This is the cool thing about a dictionary. Previously, when I was just using individual variables, I couldn't kind of make a variable of a variable. But now I'm able to say, hey, I want to say what the guess is, and I want to just choose which of the doors here is that guess. So I'm kind of writing it pretty differently than I did before. Now there is a problem with this, which is if I ran it right now, it's a little weird, and I forget this all the time, because even though this right here looks like 1, 2, or 3, that's what we're going to type, the thing is that in fact, guess is a string. Guess is text. And these, 1, 2, and 3, are actually numbers. So I got to change this guess into what we call an integer. If you remember from math, an integer is a whole number that doesn't have a fraction. Now it can be positive or negative. Integers can be -5, they can be 0, they can be 6, they can be 3. They can't be 3.15, they can't be pi, they cannot be 2.5. It can't be anything like that. Integers are only whole numbers. So we're going to convert this guess, which was a string, into an integer. And by the way, when I do these here, one of the best ways to understand code is to think about things from the inside and you go out. I just get so used to this because I've been doing it so long, but I know when you're first reading one of these things, it can be hard to decipher what this means. But if you start from the very inside, okay, I have a guess, that's here. I'm going to take the integer of guess, okay? I'm converting from whatever this is into an integer, meaning it's a number, and then I'm going to put that into the door. So whatever that number was, I'm going to look at this door up here. And then I'm going to say, okay, if that whatever door, 1, 2, or 3, if that equals a goat, I'm going to print, sorry, you got a goat. Now I just made kind of a big leap here. So any questions I have at this point, please do ask, because I know this is probably a confusing part on things of making this jump right here. Okay. What about anybody else? Any other things that you have questions or does not make sense yet? Okay. So what would happen is if you put the guess in of 1.1, I'm going to have to remember how int does this. It either will give you an error because it's not an integer, or it will cut off the 0.1. This is a great question. So what I'm going to do is this. To answer this question, I am going to see what the behavior is. And we do a lot of this in programming. We say, well, let's guess and check. So I just kind of cleared off all this stuff of putting pound signs in front of it. And I did it real quickly because in Jupyter Lab, you can press Control / and it just puts pound signs in front of all of it to make it a comment, because we use that so often. And I'm going to run this. It says, which door do I choose? And I'm going to choose 1.1. And it says value error. So basically, invalid literal for int with base 10, 1.1. It's saying, hey, 1.1 is not an integer. I cannot do it. So it won't try to automatically cut it off. And that's actually makes sense to me because Python, there's a thing called being Pythonic, which means that it should always have a very standard way of doing things and be very explicit in how it does. When we talk in the future, we're going to learn about something called PEP 20, and it's like the Zen of Python, and this is how Python should operate. So it's basically, in being Pythonic, it's saying, hey, 1.1 is not an integer. I'm just going to not accept it. Okay. Yes. Yes. So I'm going to take a guess here that maybe we have a round. Oh, you know what? I can't do that. What I'd have to do is I'd actually have to first, because I can't round it because it's a string right now, I'd have to convert it into a some kind of decimal, which is usually called a float. It has a floating decimal place. And then I would round that float, and then I would make it an integer. So it would be a little complex in doing it here. But it is possible to do. And there might be a simpler way than what I'm thinking, but almost anytime there's something possible to do, but sometimes something that you think, oh, this should be so easy, turns out to be a little bit more complex than you think it's going to be in the beginning. And you go down some rabbit holes. Yes, but that's part of programming, and that's the good and bad, and but it's as long as you take it as an adventure, I think that's the biggest thing. As long as you don't have a deadline that you're like getting the learning experience, I always find something interesting in the end. I learned something on it. Okay, any other questions here before I keep moving forward? So this is what I want to do next. Is I want to see if door number 2, and I want to have, but it's not going to be guess equals 2 because we want to try to do this now this way. Does anybody have the thought about how I might rewrite? How I might rewrite this to being more like this, so that it'll tell me I have a car. I don't want to have this in here anymore. So I'm going to get rid of that. Any thoughts about what I should write to make it more like that? I just want to see if somebody could tell me. Do you have a thought there, Riley? Oh, that's a great start. So let's see what that, with quotes, okay. So that is an interesting thing. And you might think that, right? Because you're going to say, well, if the guess is equal to 2, we know that's a car. But here's what's going to happen. And this is why this doesn't work out right. But I'm so glad you actually said it this way, Riley, because you're on the right track. Is that the guess here, they typed in the number 2, right? Let's just say they typed in the number 2. But then it converts that 2 to an integer. And so it's going to say, okay, that's an integer, that's 2. And then it's going to say door number 2. But what does door number 2 equal? Right, does door number 2 equal the number 2? Exactly. Just like this one was equal to equal goat. Really good. So I hope that kind of made sense to everybody. I'm glad we actually made that mistake in the beginning of this, because the more we can think through about what this is doing and why it's behaving the way it's behaving, the better off we are. And if this doesn't make sense yet, you might want to, if you're watching this video, rewind, pause, rewind, go through this a few times and see if you can kind of see what it's doing and what the logic is here. Now, we don't even have to do this third one anymore, because if they chose 1 or 3, that'll put goat in, and they'll get a goat. So really, we have now been able to simplify our program. And what we're doing right here is refactoring. We've made a program that was ran one way, and it's going to have the same behavior right now, for the most part. The one thing that's going to be a little bit different is it will actually never, I'm going to keep this else, print, sorry, I did not understand. But believe it or not, no matter if we type in 1, 2, or 3, it'll work. But if we type in 4, or A, or B, or anything else, these are going to fail up here. It either can't convert to an integer, like that question earlier of 1.1 didn't work, and it's going to fail with some kind of error down here. Or if we did choose something like a 4, which is an integer, there is no door 4 in our dictionary, and it's going to fail saying, hey, I don't have a door number 4. So this will still limit us to 1, 2, or 3, but we will actually, at this point, never really get this message. I'm still going to keep the message, but just want you to know that it won't have that there. So, okay. So I am going to now run this again. And somebody choose a door for us to go to. Okay, don't worry. I'll copy and paste this into the thing so you can copy and paste it in a moment, okay? There's probably some small little thing that it didn't like. So maybe a parentheses or something. But in either case, I'll put this into our chat so we can do it here. What door do you want? 2. So you want the car. And so let's go through and see what this did. It said guess, which door do you choose? And it put that into the guess variable. And then again, it said, well, the guess was 2. That's an integer, made it. Door number 2 is equal to car. So it is not equal to goat. It did not tell us, sorry, you got a goat. But the second one, sure enough, the guess was 2. Made it an integer, so that wasn't just text. Looked at door number 2. The door number 2 is equal to car. And so basically, does car equal car? Yes, it does. And you want a car. Now, right now, if a person sees our source code, meaning they see the code we're writing, they can always win, right? And even if they didn't see it, we have static things here. So they play this game a few times, they're going to probably catch on that number 2 is always a car. At first, they'll be blind, but pretty soon they'll realize, no, 2 just always wins. And then it's not really that interesting anymore to them. So what's going to be important up here is that we want to change this so that it's random, so that there's not just a predefined thing for door 1, 2, and 3. Oh yes, thank you for reminding me. I really appreciate that. Okay, so I'm going to do this. I'm going to put it over here in the chat. Right here. And now I have that in there. Do you see that, Riley? Yeah, so you should be able to copy and paste that now, and it should work for you. Okay, and what I'll probably do on YouTube is I'll probably put these in my comments there so that we also can have these things that you can be able to get these kind of major places in the code. Okay, so what I'm going to do now, I'm going to cheat a little bit to remind myself what I need to do. And we're going to do this where we're now going to start to assign random things to these doors. Now, there's a few ways of doing this. One of the first things, though, if we're going to deal with randomness, is we need to pull in a library, or sometimes called a package or a module. And actually, module is probably the most proper term here. This basically means code that's already been written by somebody else that we can use stuff from it. And the power of programming languages really comes into what libraries or packages or modules, whichever terminology that particular programming language uses, they have. Programming languages that don't have a lot of these, or they don't have them in the places that you want them, they're not very helpful. And they won't be able to let you do what you do. Python, thankfully, has this wealth of packages, wealth of things. There's many that are built in, like random, which is what we're about to deal with. And there's also so many that other people have developed. And when we dive into data science, there's one called Pandas we'll be using, and NumPy or NumPy, depending on how you want to say it, and a whole bunch of other ones. So we will be able to get those. So what I want to do first, though, is I need to be able to use some of these extra things. We use this import command, import statement, and I'm going to import in here random. That's the name of a package. And it basically lets us deal with random things. Now I'm going to still start out with door being just 2 parentheses. That initializes it. And we're still going to have 3 doors, but what's going to happen here, and this is a little weird, but it's the most optimal way, at least I can think of at first, to write this code, is we're going to make all 3 of these doors at first being goats. And then we're going to choose which one's going to have the car. And if we do it this way, it makes it pretty easy to write this. But I know it's a little weird up front to think about it that way. And as a new programmer, these things don't always come naturally. I've been doing this for so many years, it's like, oh, okay, I'm just going to initialize this. I'm going to make those all goats and then throw in this one as a different thing. So if it doesn't make sense right now, we'll go through the logic of it. And the more you do it, the more these things become more natural to you, these solutions to problems. But I definitely know in the beginning it's not so easy. For this right here, we're going to do what's called a for statement or a for loop. And we're going to loop around door. We're going to do 3 different doors. We're just going to go 1, 2, and 3. So 1, 2, and 3. And I'm going to use an old style variable that's commonly used called I, which I think just stands for iterator, because it's going to go through 3 iterations. And so I'm going to do for. Okay, well, if it does die, you can always come in here with me, okay, Riley? Well, I know. It's just if you could bring your Chromebook in here with you, okay? Yeah, go ahead. You can bring it in real fast, and we'll charge it here. You can do it. Just bring it over here. I'll charge it, and you can do it while you're with me. No, you can keep mute on. Actually, wait. It might echo. So mute your mic. Okay, come on over here. Don't worry about the door. Just come on over. Okay, we'll have to take this out of the video, or maybe the audience will just have to be patient a slight bit. Can you turn your speakers down? We don't get an echo. Okay, so what's going to happen now is I am going to go in here for I, which is an iterator, and this is making a new variable. We haven't had a variable I yet. And I'm going to say for I in, and oftentimes we use something called range. If you look at a whole bunch of beginners tutorials, they will do range here, but I found that doing this the last time that it didn't make a lot of sense. And range is kind of this weird one because you say range 1, 4, and that really means 1, 2, and 3 because you leave off the fourth one. So I'm going to do this hopefully in a way that's a little bit more understandable, which I'm going to say for I in 1, 2, 3. So basically, it's going to do I, and it's going to say it's going to do I for 1, for 2, and 3. And I put that colon at the end. Something also I did not mention earlier with these if statements, you notice how it does an indent after I put that colon in. Python, it's critical that we have these indents. A lot of languages, it's good style to do indents, but it's not required. Python absolutely requires doing this. And if you have a good editor, like Jupyter Lab here, or a lot of other editors, they'll just do this automatically. When they have a colon, they're going to say, oh, that's indented. The next thing is going to be indented there. Another word for editor, by the way, I did not mention this earlier. Sometimes you'll hear these called IDEs. That stands for Integrated Development Environment. And it's basically fancy word for editor because we can edit the code and run at the same time. And so it's integrated. A long time ago, you had to write your code in a text editor, and some people still do this, and then they go back and they run it in their thing, or they compile it, or things like that. Luckily, we don't have to compile things in Jupyter. It's not a compiled language. It's an interpreted language. So, getting back off of that tangent, for I in 1, 2, or 3, we're going to say door I equals goat. So what's going to happen here is this is going to go through and it's going to say, okay, what's I? Well, I is 1. Door 1 equals goat. What's I? Now I is going to be 2. Run through this door, I equals goat. Go back to the top. Third one's our last one, so I is now 3. Door 3 equals goat. It initializes this. And in fact, because it's a little confusing, I'm going to put a comment up here saying initialize doors. Initialization is a very common thing we do in programming, so we're going to initialize all of these. Now once the 4 is done here, I am going to next, now that we have 3 goats, basically all the doors are goats, I'm going to choose one randomly, and that random one is going to become a car. So what I'm going to do is I'm going to say door, and then bracket, and I'm going to say random randint. Randint means generate a random thing, and the dot here basically means grab randint from the random package. So it's up here. Door dot randint, and I'm going to have this randint being between 1, 3. So door randint between 1 and 3 is equal to a car. So what does this do? This basically chooses a random integer. That's what randint does. It's a function from random as our package or module. And then door, that was 3, or 1 or 2, whatever one it is, whatever this random thing is, it equals a car. So we're going to now, just for testing purposes, again, we do this oftentimes for testing, we're going to put another print statement here just to kind of see what it shows so we know ahead of time. So you can see that it's really doing it. And we're going to, I wrote this out before, so I'm going to give me a moment here. Oh, that's what I did. Okay. And I'm actually going to do this a few places here. I am sorry. I'm trying to remember what I did last time. I'm going to write it out up here so that right after it does a goat, we can see that all of them are a goat. And in fact, I'm getting a little bit ahead of myself. I want you to see that all three of these are goats at first, and then we're going to do this car. So I put a pound sign here in front of car. Just hold off. Be patient. It's okay. So what I want you to see right now is that what's going to happen is it's going to just tell us there's three goats. Goat, goat, goat. Before it chooses the car. Because I have car where it has the pound sign. And then I'm going to undo this one right here where one of them becomes a car. And I'm going to say the same thing here. Oh, actually, I can't do that anymore because, yeah, I can't do that. I'm going to pound sign this. Okay. It's now choosing a random car. And actually, this is the full game, at least for where we are right now. So this is what I'm going to do. I'm going to run this right here. I will copy and paste this into our chat.
Yeah, because I'm so confused right now.
Yeah. I know. Sometimes it's hard to keep up with the typing here. So I'm going to copy.
You're typing real fast.
Let me go back to chat. This is our program. I'm going to send this right now. When I run this, now that we have a random car, that's kind of weird.
Wait, it didn't show.
Yours asks you which door you chose. Okay, go ahead and do yours. Mine got stuck for some reason. I'm going to interrupt my kernel.
Mine doesn't show go, go, go.
That's okay because you have the pound signs there. It won't show go, go, go. Mine won't show go, go, go either.
What was that?
Probably somebody here. Oh, Jedley wants to come back in. Okay, here he comes. Okay, so on this code right now, what's going to happen here is I'm going to run it. It should run this time. It pulls in that random module, which we're going to use later on down here. We're going to initialize these doors, meaning we're going to figure out what the doors are. At first, the door dictionary is going to just be brackets. Then we're going to run a loop, and we're going to make everything a goat at first. So it's going to say for I, meaning iterator, in 1, 2, and 3. It means it's going to run this 3 times. Door I, door 1, first time, will be equal to a goat. Door 2 will be equal to a goat. Door 3 will be equal to a goat. We do that because it's easiest to get all the goats in there first, and then just to change one of them to a car. As opposed to trying to put the car in, and then we have to do more complex things of saying, hey, is this already a car? Okay, if it's not, make it a goat. We could do that, but it's actually more complex.
I want a car.
So now, okay, hold off one moment, Riley. So now that we have our door and our random thing, it becomes a car. And then we guess. And then if it ends up being a goat, just like our stuff we talked earlier, then we get the goat or a car. So if I run this, I'm going to choose door number 1. That was a goat this time. If I run it again, I choose door number 1. I want a car. Each time we run this now, it will be different. And this is the full initial program. And we actually covered a whole bunch of different things here. We covered basic variables. We covered integers. We covered strings. We covered packages. We covered dictionaries, which is a type of variable. And we covered random numbers. One thing I meant to talk about with the random numbers here is when we do random numbers, these are actually called pseudo-random numbers, meaning kind of false or fake. Pseudo means that P-S-E-U-D-O. And they're not really real random because if you knew how they were created. They have something like called a seed of the time and date and a whole bunch of different things. You could predict what the end result would be. And in fact, there's two different types of randomness actually in the world. One called aleatoric, which is meaning flipping a coin where it's truly random, at least possibly truly random. We'll talk more about that later. And one called epistemic uncertainty, which is if you knew all this stuff, you could be able to figure it out. Some people say everything's epistemic uncertainty. There is no aleatoric. I'm a believer there is both, but we may never actually be able to know, and that's a philosophical question, which we'll dive in deeper about things later on that. So we learned about random numbers, and then we also learned about inputting and guessing. So we covered a lot. Now, hopefully, with this video, if you did not get it this time, or you were not able to see the whole lecture, you can come back to this and look at the parts and fast forward and rewind, because I'll be saving all of this. The other thing is that the goal for this week is to add on to this program. To basically, before telling them they got to go to a car, to add something after this guess, and to make the Monty Hall program where Monty gives them a chance, where you print out, do you hear, behind this door is a goat, and tell them the door. And do you want to change? So we want to basically make the real problem. Right now we have a simple game, and we want to make it like the real Monty Hall problem. And then what we're going to do is we're going to take that, and we will convert it into what's called a Monte Carlo simulation. We have a lot of Monty here, although that is M-O-N-T-E for Monte Carlo. And a Monte Carlo simulation is going to run this program over and over and over again. It's going to be a big loop. And what's going to happen when we have that big loop is we are going to be able to then see what happens when we choose different numbers and see is it better to change or not change. If you look up the Monty Hall problem on the internet, you can find the answer. It might not make sense to you yet, but we will prove to ourselves which is the better way to do it by just simply making this Monte Carlo simulation. That's what we'll do next week.